Hi, my name is Narjes Pourjafarian. I'm a doctoral researcher at Saarland University, and together with my colleagues, we wanted to find a way to create epidermal interfaces directly on the body. So, we present BodyStylus, the first computer-assisted approach for on-body design and fabrication of epidermal interfaces. Current approaches for creating epidermal interfaces typically have three different steps: designing the interface on a computer, fabricating the design, and then applying it to the body. But this is fundamentally different from how traditional body arts and crafts are created. As you can see, traditional on-body arts and crafts like henna or tattoos are adjusted to the body as they are applied. We wish to do the same with electrical circuits and present an approach that considers both the functionality and aesthetics of the design. For our BodyStylus system, we took inspiration from the traditional handheld form factors of henna and tattoo arts. Our stylus consists of a Neo Smart Pen, which helps to track the position of the pen on the body. To make interactive traces, we fill the cartridge with sinter-free gold ink. It means it doesn't require curing after fabrication. In addition, we also added a micro-servo motor, which allows automatic retraction. The overall setup I've just shown you allows ink on the body and simultaneously tracks the pen's location. However, it is not sufficient. Designing aesthetic epidermal interfaces on the fly is demanding. The user should consider the functionality of the created electrical circuits and the desired visual appearance. To support users in this task, we implemented guidance and constraints functions. Guidance provides the designer with options. We use a projector that projects visual cues on the skin. Constraints prevent mistakes through our computer-controlled handheld tool that switches between inking and non-inking mode. The concept of constraints has been presented in prior work in SIGCHI, for instance by Zoran et al. Together, guidance and constraints provide a two-dimensional space for interacting with BodyStylus. As I mentioned, guidance assists the user to make a circuit, for instance, by highlighting terminals to connect to, or helps to draw aesthetic elements. BodyStylus provides different levels of guidance: free inking, minimal guidance, partial guidance, and full detailed guidance. The user selects a suitable level based on her expertise. As I explained, the inking tip of the stylus retracts whenever the user intends to violate the logic or aesthetic constraints. Here, for example, the user is going to create a short circuit, but the constraint prevents it. Constraints also have different levels. Without constraints, the user draws freely. When the user selects a strong constraint, the system prevents any inking that was not planned. To summarize, the user can flexibly decide to benefit from more or less guidance or constraint. To evaluate BodyStylus, we invited two groups of engineers and makeup artists to use the setup. Both groups were able to adapt to the workflow. An observation we received was that while artists found guidance more helpful, engineers preferred to use constraint more often. For more details, we invite you to have a look at our paper. BodyStylus enables fabrication on various body locations at different scales using various input and output modalities. In summary, I presented BodyStylus, a novel interactive approach that allows us to design and craft epidermal devices directly on the body. We use a handheld fabrication tool and self-sintering conductive ink. We leverage in-situ projected guidance and physical constraint to facilitate the creation of functional and aesthetic epidermal devices. Thanks for listening. Looking forward to the discussion.